Let's go through some more examples. Number 4, your soccer ball holds approximately 360 cubic inches of air. What is the approximate radius of the soccer ball? So now we're going to have to back solve, solving for the radius when we're actually given the volume. A soccer ball has the shape of a sphere, so we're going to use the formula for the volume of a sphere, and that is V is equal to 4/3 pi r squared. And again, a reminder, you don't have to memorize all these formulas. They are on the formula sheet, so go ahead and use that to find it out. We know the volume, so 360 is equal to 4/3 pi times r cubed. Now let's go ahead and solve this equation for r. First, we want to get rid of our fraction. That means we're going to multiply by the reciprocal of that fraction. 3/4 times 360 is 270 is equal to pi r cubed. Now let's get rid of pi by dividing by it on both sides. 270 over pi is equal to r cubed. And in our last step, we're going to take the cube root of both sides. And now is the time to use the calculator. And you're going to find that r is approximately 4.4. And what is the unit we're using here? We had volume in cubic inches, so the radius has to be in inches. And there is our answer. Example 5, part A. Two similar cylinders have heights in the ratio 2:5. The smallest cylinder has a radius of 6 centimeters and a height of 8 centimeters. What is the volume of the larger cylinder? So we are obviously supposed to find volume. What is the formula for the volume of a cylinder? We have used this before. Again, look it up on your formula sheet. V is equal to pi r squared times h. Now we have the information of the smaller cylinder, so let's go ahead and find the volume of that one. We're going to use that to find the volume of the larger one afterwards. V is equal to pi times 6 squared times 8. And so our volume, let's keep pi here for the time being, is 288 pi. All we are given in order to find the volume of the larger cylinder is the ratio between the heights of those two cylinders. All we've been given to find the volume of the larger cylinder is the ratio between the heights of the two cylinders. And ratios, scale factor, is something that we have used before. Remember, we had the ratio of lengths, which is the scale factor, the ratio of areas, and the ratio of volumes. Areas and volumes and everything else is length, right? So heights and radii are lengths, and the ratio of those is 2:5. And how do we get from our scale factor, which is the ratio of our lengths, to the ratio of our areas? We square it. So 2/5 squared is equal to 4/25. And to get to the ratio of volumes, we have to take our 2/5 and cube it, and we get 8/125. That's the ratio we're using for the volumes. So 8/125 is the same as our volume of the smaller cylinder. That has to go in the numerator because the smaller number, 8, is also in the numerator. 288 pi over x, the number we're looking for. And now we have set up our proportion, and all we have to do is solve it by cross multiplying. 8x is equal to 125 times 288 pi. That is the same as 36,000 pi. And now let's divide both sides by 8. And x is equal to 4,500 pi, and we can get the decimal for that, 14,137.2. And what is the unit of this? Our radius and our height were in centimeters, so the volume is in cubic centimeters. In our last two examples of the day, we're going to explore what happens to the dimensions of an object if we change one of those dimensions. In part B, if the height of the smaller cylinder increases by a factor of 4, by what factor does its volume increase? We're talking about the volume of a cylinder, and we're increasing that by a factor of 4. Factor means we are multiplying. The volume of our cylinder is V is equal to pi r squared times h, and I'm going to call this V sub 0. That is the volume of the cylinder before we have increased its height. And now we're going to explore what happens to the formula after we have increased the height by a factor of 4. We don't need any numbers for that. We just keep using the formula. V sub 1, so after the increase of the height, would be pi r squared times 4 times the height. We have a height that is 4 times as large as before. Now, if we use the associative property and rearrange our formula, we can write V sub 1 is equal to pi r squared times h times 4. And remember, pi r squared times h is really what we said was the volume of our cylinder before V sub 0. So we can substitute that, and that is then V sub 0 times 4. So that gives us the factor that the volume afterwards is larger than the volume before. The factor is 4 times. The volume will also increase 4 times. What would happen to that same cylinder if the radius is increased by a factor of 4? What would be the factor that the volume then increases? And we're going to do that the exact same way as we did before. Our formula is still the same. Our volume of the cylinder before, so V sub 0, is equal to pi r squared times h. And what is the volume after the increase? V sub 1 is equal to pi times 4r squared times h. Now we need to distribute our exponent 2 to both the 4 and the r. That means we got V sub 1 is equal to pi times 16 times r squared times h. And by rearranging this now, we get pi times r squared times h times 16. And again, pi times r squared times h is what we had used to describe the volume of the cylinder before. So we can substitute it, and we can write V sub 0 times 16 is the same as V sub 1. So now the factor is 16 times. And why is that? Of course, because the r that's in the formula gets squared in that formula. We can do this without even knowing any numbers, because it's going to be true for whatever number the radius is and whatever number the height is. If we just multiply either one by a certain factor, then this is what's going to happen to the volume of that object. So we could do the work without knowing anything, and you see that the factor with which the volume changes can be different, and it depends on how the respective variable, height or radius, is used in that volume formula. Alright, so much for this, and I will see you in class.